Okay, are you able to see my screen? Yeah. So basically, we're going to be talking about queues, which is mainly the same thing as stacks, except that it's kind of first in, first out. The stacks are last in, first out, because the last that it was added will be the first one to be removed, and that's the stack. So the queue is kind of like a queue. If someone comes first, he'll be the first to be served, and that's the idea. So for this queue we have basically the same, actions, but we give them different names. So we don't have push, but we have enqueue. We don't have pop, dequeue, and that's it. So now if we have a queue, now if the implementation, let's say, is a double linked list, we can have the same discussion like of the stack, because the queue can be in an array or in a linked list. Now if we have the linked list implementation, let's just talk about this and draw things around. Now imagine we are talking about, now this is a queue. So if I enter, let's say if I put 5, then 2, then 7. So when I'm removing, so now I'm adding to what if I'm using a list? The way I added it is add to. So we add to the tail. Now if we add to the tail in a queue, if I'd like to dequeue, I would dequeue from the head. So the first one will have to go is from here, so the 5. So when I'm enqueuing, I'm queuing to the tail. When I'm dequeuing, I'm dequeuing from the head. So if I have this implementation of this method, if I'd like to implement those methods to put them in my queue, which is a double linked list, then every time I enqueue, I add to the tail. Every time I dequeue, I remove from the head. Now this is one way. The other way is that I do it differently. Like if I put 5, then 2, then 7. Now, which means when I'm enqueuing, I'm adding to the head. And then if I'd like to dequeue, so I remove from the tail. So 2 ways how to handle that. But the idea is the same. The first one that's in is the first one that's out. That's what we call this FIFO. And first in, first out, and LIFO, last in, first out, that's the stack. The rest is basically the same, is empty, clear, first element. Now the first element, depending on how we implement it, now the first element would be 5, which is looking from the head. So this first element is we look at the head. While here the first element, in this case, we look from the tail. So basically, depending on how you implement it, you're just going to be consistent. If you choose to add to the head, that means you're going to be removing from the tail, and your first element is going to be in the tail. If you add, I said add to the head? No, that's not how. If I add to the head,
You remove from the tail.
I remove from the tail.
Yeah, you're right.
So I was right. I got confused. And then if I add to the tail,
You remove from the head.
the first element is from the head and the remove from the head. Yes. So that's basically it. Now there's some kind of interesting implementations, and there's something also called this priority queues. We'll be talking about them maybe later on. But for the there's something in terms of the implementation of the array implementation of that is kind of interesting, where you can have some kind of a circular array to implement that. So a circular array basically is just an array, but we imagine that it is circular logically, but as an array, just like places in the memory, so there's no shape that is circular. But the main idea is that you remember where is the first and where is the last, and how you know that this queue is full is that you have two situations where either the first is the first one, the last is the last one, or the first and last are next to each other. And if they are not next to each other, that means, well, it's not full. And that's the idea. The idea about this circular, so you don't have to always worry about if you add. So should I just have always the first one to be the first index, the index 0, and the last one is whatever we arrive. But now if I dequeue, I'm going to remove from the head, right? So which means I'm going to have to move from the head, put each one of these and put them back to the place. I'm trying to show you why this kind of, why do we need to talk about this circular, why they come up with this circular implementation of an array, of this queue as an array. Because if we don't look at it as circular, if we look at it like this, that's some kind of sequence. Now this is the first, which means the first is going to always be the index 0. And then what if I put like 5 and then 2 and then 7, so whatever, this is where my last is. But if I dequeue, now this is the problem. How can I handle this? If I don't look at it as this is something that is circular, if I dequeue, I remove this one, now the 2 has to be moved here, and the 7 will be moved here. Now imagine a queue with 1000 elements. Every time I dequeue or enqueue, now if I enqueue, same thing, like I dequeued 5, now I'd like to enqueue 5 again. Okay, I need to, this one, this is my array, is going to be having 2, 7, whatever. If I would like to enqueue 5, which means this 7 should be copied here, this 2 should be copied here, so I can make room for 5 to be here. Something like that. Because
The last one.
when I'm enqueuing,
Yeah, it should be the last one.
well, you're right. When I'm enqueuing, this is not the problem. When I'm enqueuing, I'm not enqueuing to the head. I'm not enqueuing and put in first, because if there was something in it, so when I'm enqueuing, this is not happening. If I enqueue 5, the 5 should be here, because there were some other things that were there first. So this was still keep their rank because it's a queue, and that's not a problem then for the when I'm enqueuing. The problem is when I'm dequeuing. Now if I'm going to, let's say, imagine that this is circular. Now the idea is that it's basically the same idea, except now my first and last, what's the idea behind that is that let me just clear this. Now the idea behind circular is just like this thing, the same idea, and my first is here, but instead of moving things, if I add something, if I enqueue, for example, this is 5, then 2, then 7, that means my first is here. Now if I dequeue, I'm going to remove this one, and then my first is going to move to be here. Now if I'm enqueuing again, I'm enqueuing to the back. So let's say I put 10. So this is again 10. And if I'd like to enqueue, 11. If I'd like to enqueue again, well, I can just go to the place where the 5 was. And that's why it's going to be easy if I look at this as a circle. So Imagine I started here and I queued 5, then I queued 2, then I queued 7, then I dequeued 5, which means now this is the first one is pointing here, and then I queued 10, then I queued 11. Well, my circle was not the same size of this array. Let's just make them the same size. And then I'm in queue 15, which is the whole, this big thing is all 15. And then if I'd like to enqueue another number, let's say 5 again, well, there's still a spot available, so this is where I'm going to put 5. Which basically is just when I finished, I just go back and there's still an empty spot, and this is what I'm going to put, the 5. And then this is going to be my last, and this is my first, and that's how we look at it circularly, just to avoid having to do this kind of moving around the data when I'm enqueuing or dequeuing. Yes, dequeuing, unqueuing. It's when I'm dequeuing that I have to move them if I'm not using this technique of looking at it as circular. Yes.
So the array should we know already how many index on it?
Well, there is a max, yes, but again you can use an array list,
Yeah.
and an array list is going to grow. Yeah, so we can have this kind of implementation using an array list. Let's go back here. I did not start the presentation. So I mean that's an array queue when you have to like say for example they initialize that with a set of size, so they say okay it's 100, and then if we need we can increase if needs to be. But this is not an array list implementation, this is an array implementation of that, because they declare the storage to be an array of objects. It's not an array list. And then we have this array queue. If I don't specify what's the size, the default size will be 100. Or you have another constructor that you can specify the size, and then your size is going to be that n, and then the initialization of the storage is going to be this. And then we put first and last to be -1. They're all ints because they are indices. And then is full, that means if the first is equal to 0 and the last is equal to the size -1, which means either we're in this situation or the first is equal to the last plus 1. We're in this situation. So if we're in this situation, the first is equal to the last plus 1, or the first is the first and the last is the last index, then this is how we can say that this is full. If it's empty, that means that it's -1, because we're going to change that. Every time we enqueue, we check if it's possible, and then we put it, and then we change the first. And if it's not like this, we just increment the last, because remember when we just add to the end. So the first doesn't change when we add. When we add, the last is the one that changes. The position of the last who changes. Now if I add something, so when I'm enqueuing, that means the first is not going to change, but the last will. The last is going to be updated. And when I dequeue, it's the opposite. So if now this is just a situation where if the first is equal to the last, that means it's empty. We're not going to, there's nothing. And no, if the first is equal to the last, that means this means what? That means we dequeued the last one. When is the first is going to be equal to the last?
One element.
Exactly. If there's only one, no, it's just okay. Cancel. Now, if I have only one, where's I cannot. Okay, I cannot erase it. No, actually, when I have only one. Okay, let's maybe. Okay. Let's just do it differently. All right. No. And fill. But no colors. I just would like to have. Okay.
Where is it?
No, there's this better. I'm just drawing on top of that. So now, oh. I just went too quickly. Okay, now I can change it. So if now if this is empty, that means the first is equal -1, which is the same thing as for the last. The first and last are -1. Brush. So when this is empty, the first and the last are both -1. Now if I insert in Q1, let's say in Q this 5. Now the first is 0 and the last
0 also.
is 0. So that's why I'm asking this question here. If the first is equal to the last, this is a case when we have one element. And if I dequeue, that means it will become empty. So that's why this becomes like this. If the first is equal to size -1, what does this mean? That means the first is here. So if the first is here and I'm dequeuing, what should happen?
Now the first should be go to 0.
Because now the first was here and then I'm dequeuing, that means the next one is here. So that means the first will become this one. That's what is happening here. So then first is equal to 0. And if it's not in this situation, if it's here, for example, and I'm dequeuing, the first is going to be the next one. So that's why else I'm just going to increment the first. And then I return whatever was in the first. But what if it's empty? Now this code is not complete. Because what if the queue is empty and then I'm dequeuing? If the queue is empty, that means first and last are equal to -1. And if you do this, you have array index out of bound exception, because there is no index -1. So we need to do something to improve that. But anyways, I'm just trying to. They're focusing more here on just showing the steps as what happens when I'm dequeuing, not taking all the possible actions that can be taken. Yes, Sally.
With this equal size -1.
This one?
Yes.
Yes. Why?
Why it's first the last one, but when we dequeuing, we make it the index 0.
I'm not sure to understand the question though. You said, okay, let me just do one thing.
In this condition,
Yes.
the first is the last one.
The first
size
is
-1. Last one, yes.
hold on, sorry, let me, okay, fine, good. Now I'm ready to go and then brush. Now you're talking about this here, right?
No,
The-
this condition, first equal size.
Yes.
It's the last one. The first.
No. Means the first and the last are the same. And the first and the last are in the same place. The same index is the first and the same index is the last. And this can only happen in one case, when we have only one element. So if we have one element in a queue, the first is here, the last is here. So that's this test here is just to check, are we having the first element, only one element in this?
I don't want this.
You don't want this one?
The second condition.
The second condition.
Yes.
Okay. Okay, sorry. Then what about the second condition? Yeah.
First is the last one, yes.
Okay, now exactly. Now if the first is here and I have 2, 7, again this is like some kind of circular, right? So this is where the first is, this is the last. Now I'm dequeuing. What should happen?
Fine.
This should be removed.
Yes.
And then the first, where does it go?
Two.
The 2. So this becomes my new first, which means the first now is 0. So if it was the last one, so and then dequeuing, it will be back to the first. If not, if it's not like we have only one element in the queue, and if you're not the last one, then just move it. When we dequeue, we just move the first. If we have something like, let's say in any other condition situation, like we have this is 5, 2 and 7, and this is my first, this is my last, and if I'm dequeuing, just the first needs to be incremented. So that's the dequeue. And this last one, do you know what this is? java.utils.arrays.toString storage.
It's gonna print something?
It print them all the content, because this array toString is going to just, it takes this array of whatever it is, and then it's going to be printed one next to each other with some brackets in between and some commas, I think. Now the linked list implementation is kind of easy. This is the first thing, except now if we look at this thing, this is the linked list implementation. If the first element is get first, that means what? When we in queue, where do we put things? Now we're talking about linked list. Okay, let me just erase everything.
Single or double?
Okay. Now if I have a linked list, if I put 5, well, let me just represent this way. I put 5, and then we have this double linked list, whatever, and then 2, and then 7. If the first element is get first, that means when I'm dequeuing, which one am I dequeuing?
It depends if you are
Well, you see, it says here, get first. This is the first element. So that means my first element is,
ahead. So it's I don't know.
Well,
tail.
it's the head, because we remove the first. But what is this remove first? Because actually, based on the implementation, maybe remove the first is the first element of the list, which is remove the head, basically, because we have add to head and remove or delete from head. That's why these are they were kind not that clear. But anyways, and this add list add, because remember, this is a linked list. This is the one that comes from java.utils.linked list, and this one, I forgot to start NetBeans splits too. And this one, when you get the first, it gets you the one from the head, and if you add, it adds to the tail. That's why you see, just when you in queue, it just use add, which is add to the tail. How do I know that? Well, let's just open it to see it. Yes.
What's the more efficient, using array or arrays?
Well, which one is more efficient, the array implementation or the linked list implementation? That's your question. And well, it depends. It depends on what? Well, it depends on how much often your size is going to grow. And if you have a short list and then you don't need that extra storage is a problem. That means you don't have a lot of it. The linked list implementation takes more space than the array implementation, because you have the value, then the next, then the previous. So you have 3 spaces in the memory for every index that you have, plus the head, plus the tail. So we're not talking about the head and tail, because we have first and last also in the array list, in the array implementation. Now, so you have to, there's no just one way that is the best. It depends on what you have. Let's say you have a shortage of memory, then maybe the array implementation might be suitable. But then if you're doing also, but for the queues, probably not going to be inserted in the middle, which is a problem with the arrays. Like if you'd like to insert something in the middle, delete from the middle, then it's going to be a problem to move things around. So, and with the queue we don't have that problem, because the queue is always a queue in one place, the queue from the other, and there's no problem to insert something in the middle. So that's not a problem about having an advantage. The linked list is not having that advantage. So the array might be more suitable, but it depends. If you're using, for example, very large numbers, and then or maybe you don't know how many values you're going to have, you have to decide to define an array with a set of size, with specific size. So this might be wasting some space though. So you don't know exactly, so you just say, okay, I put 100. Maybe you're just going to put 3 on queue 5 numbers. So 95 spots in the memory are wasted. While if you use the linked list implementation, you're just going to use 5 plus the 2 extra things for each one of them, which is still less memory than the array implementation. So it's not like white and black, and it's kind of, you have to look at the situation that you're in, what are your constraints, and then you decide which one is more suitable based on exactly. Yes, I wanted to open NetBeans, which probably is open. Yeah, let me just go back to some of these. Okay, I can close these, close somewhere. Yeah, and if I go back here just to see some kind of linked list implementation. Okay, now if I click here and I'm looking for add, and add, you see it says linked last, which means it adds to the tail. And first, get first gives me the first element, because it gives you f, which is the node dot item, so it gives you the first. So that's why when we use this implementation, the get first is the head. Get first, this one, yeah, is the head, and the queue is removing from the first, because with the queue from the head,
So then why it's like stack?
with the queue from the head, no, but we add to the tail.
We add it to the tail.
Yeah, with the queue from the head, because if I remove, where is this remove first, so we remove from the head and link the first, and then when we add,
Add to the tail.
we add to the tail, to the last. So that's the implementation. Okay, so this is some kind of another representation of that, and the priority queues are something kind of like a queue with wasta, let's say. I don't know if it qualifies, but I'm sorry, I cannot hear. Emergency. Well, yeah. Well, this is something that is used a lot in let's say process management. Now, if I look at this, let's go back here. The task manager. Now, there are a lot of processes running in the background, and we have only one CPU. But some of them have, I mean, this one is not really, this one is not really showing a lot of data. I don't know, can I see some column? Yes, command line, no, status type. No, normally I want to see the priority. Every process has some kind of priority. There are different levels of priorities, and I'm not seeing, yeah, this is just a process ID. It's nothing that is the type. What is type? Well, no. Publisher, not interesting, so no, we don't have that. There's one tool that I used to have, I don't know if I can find it here,
Maybe in details.
or here.
Task manager.
Process manager, yes. I don't know if I find it because it shows actually the, anyway, I don't remember where I put it. So probably in my, okay. Let's see if I have something. Process Explorer, it's called Process Explorer. Let me just get this one and let me run this one. It will ask about this is a network drive, probably agree anyways. Let's see if we can get something. Yes. Now these are the processes, but what's interesting as well, I can show the process. Where is it? Base priority. Now this is the base priority for processes, let's say. Now some of these processes you can see some have 8, some have 0. This is system idle, so it's just idle. That means the CPU is doing nothing.
Yeah, doing that.
Now 8, then we have 11 and 13 and 9, and these are most of those are 8. So this is some kind of level of priority. So if one that has a higher priority comes, and all of those that are in queue waiting to access the processor are a lower priority, then this one is going to be passing first. Let's say if you're running now, the processor is using, I don't know, it's working with Word, and then there's one process that is the operating system thing that needs to be the operating system that needs to be doing something.
Like shutdown.
For example, then like the shutdown, then this will have higher priority, so it will start even if Word is still doing something, but Word is going to be interrupted because there's a higher process that is coming. And you can right click here and see this set priority, and you can see some kind of different levels of priorities. So normal is 8, below normal that's 6, idle that's 4. So that means whenever the CPU is idle, then it's going to be able to access the CPU. If the CPU is busy, even with any other one, is going to be. Anyway, they're different levels, and real time is the highest. So that's this type of priority queue. I think we're going to be talking more about them later on, but that's the main idea, and whatever, we'll talk more about those more. So just to summarize, queues are like stacks, except that it's first in, first out, and we're going to be just practicing, just doing some kind of exercises just to do the same thing that we did in the queues, in the stacks. We're going to do them in the queues, and that's all about that. And these are the exercises. So, well, the first one are kind of very similar, very simple, but then we get to do some kind of add some methods to the singly linked list, and you have this get last, get first, and you have to use just the correct ones, and that's pretty much it. What is this? Oh, why is lab 1 is here? I'm looking. Oh, sorry, I'm looking at the wrong thing. Yeah, I was looking at the wrong thing. Yeah, so this is the array implementation of that. So, and then we're going to be using the double linked list queue, and I'm going to add more exercises, but these are like the simple things to start with. But we'd like to also use something about the array implementation, so I'd like you to work with that too. Yes?
The assignment until here, or we cover something else?
Until here. Yes. Until what we do this week.